Hello, everyone. Welcome to my talk, Certified Double-Sided Auction Mechanism. I'm Suneel Sarswat from Tata Institute of Fundamental Research. I thank all of you for your fantastic presentation. So let me give the background of the problem. So trading, this problem is about trading. So trading is a very important part of any economy. And we know that the trading usually is conducted by exchanges in a formal market. So the traders places their request via computers to an electronics exchange, and the exchange executes these trading. The whole process is very complicated because of various regulations in the market, as well as the various types of requests are allowed in the market. And so the whole process is complicated. And there have been instances where stock exchange has failed to um, implement the regulatory guidelines set by the market regulators. So there are many such instances. These are some of them where they have failed to execute the matching algorithm guidelines. So we want to solve this problem. So our goal is to have a fully formalized trading system with complete specification. So that is our goal of the problem. Before I get into how we do that, let me give you a brief introduction about how the matching is done at the exchange. So trading is done usually uh, by two types of algorithm. Okay, so stock exchange conducts these trading in two different sessions. They call one is called the call auction session, which in which they use an offline algorithm where for a fixed duration of time they collect buy and sell requests from the trader, and at the end of this duration they matches. Some of these buy and requests are matched as per some rule, and then at the end of this time period they execute all these trades simultaneously at a single price. Okay, and in this session they use double-sided auction mechanism. They also use another algorithm which is for the continuous trading, and that there the trading happens as in when a request comes. Okay, so in this case two buy requests come, now a sell request come, and it is matchable. Okay, so it will be matched. Okay. And this is how so I'll not get into this more detail. So our contribution is to formalize. So far we have fully formalized the call auction session. We have modeled the double-sided auction mechanism, which is what they use in call auction session, offline algorithm. And we have formalized some important properties related to stock market, like individual rational, fair, uniform, maximum matching. We have formalized two classes of algorithm for double-sided auction, including the one which is used in the market. And we have proved that these algorithms has the desired properties. And now we are extending this work for multiple quantities. Note that this work was done for a single quantity trade request. We are also working on the formalizing continuous session. Okay. The issue with the continuous session is that the theory for the continuous session specifications are not known. Like for the double-sided auction, some of the theory were known in the auction literature, but for continuous session, that is not known. So the first thing is we need to discover, or we need to come up with the natural specifications. So we convert the complex order types into simple order types. Then we identify some three natural properties. And we formally prove that these property imply a unique input-output relation. That means the specification is complete. And now we have a natural algorithm after the specification, and we show that this algorithm has these properties. So far I've just discussed the background and what we have done. and what we are planning to do. Now I will get into a little bit information about both the work. So these four properties, I will just give you brief introduction about the four properties which we have formally proved on the algorithms as well as the matching. Individual rational is a very simple property, though it is a very important and desired property. It ensures that the trade prices should always be between the limit prices of bid and ask. So bid is the buy request, ask is a sell request. And the limit price of a buy request is the price above which buyer is not ready to buy. Okay, and the price for limit for the seller is below which the seller is not ready to trade. Okay, so this property ensures that it should always be between them. The other important property for the market is the fair. Okay, fair ensures that competitive traders are given preferences in the market. So here is a small example. Bid is the collection of buy requests. The number corresponds to their limit prices. Ask is the collection of sell requests. The line denotes the matching. Okay. So here is a matching of size 3, and we convert this matching into a matching which is fair on bid. Okay, so we take the best matching in best bid and replace it with the best bid in the list. Okay, list of buyers. Okay, so now at the end of this process, the matching gets converted, same size matching get converted into a bid. Similarly, we do that for ask. Okay. Then we have an algorithm which gives a maximum matching. Okay, this is important property in the stock market because we want to maximize the total trade volume. Okay, so this algorithm, I will not get into the detail how, but we can take. I can take it as a question. So I will just show you in the animation how does this algorithm work. It tries to find the maximum pair, matchable pair, and then converts that into a fair matching. And then we also model the uniform matching. This algorithm is used in the stock market for a call auction session. So this algorithm gives the maximum possible matching, which is uniform. Uniform means at a single price, all the trades can be executed. So in this example, at a price 20, all the trades can be executed. No buyer and no seller will complain, and this is the largest possible. For the continuous session, as I said, the theory is not known. So first thing we do is we try to see what is the issue. So the reason is that the traders can place complex order types, and these order types depends upon the stock exchange to stock exchange. Some New York Stock Exchange follow different order types, and Bombay Stock Exchange follow different types. So what we do is we break the problem into two parts. One is scheduler, which is exchange or the market specific, and the regulations are handled by some of the broad regulations are market specific regulations are handled by scheduler. It converts the order, the request, the buy and sell request into simple orders, and the simple orders then handled by a core engine which executes to the trade. And then we give the specifications for the simple order. There are three natural specifications. One is the price time priority in the trades, which ensures that the trading is fair. Then the positive bid ask bid. This specification ensures that you should maximize the trade on the arrival of a request. Okay, that is online algorithm. And the conservation, this ensures that no arbitrarily treatment of the buy and sell request. Okay, and finally we prove that these specifications implies a unique input-output relation, and that we have a unique algorithm. This was a joint work with my advisor, Professor Raja and Abhishek. The preprint is available at archive, and the Coq formalization is available at this. Thank you.
Thank you, Suneel. Okay, there's a question from Tree.
Hello. I find this question is very interesting, but I wonder, you introduced some property like uniform, fair, and something like that. I wonder, is there any priority between this property? And if there is some conflict here, which one you will guarantee it's in higher priority?
Okay, so it is known that not all the four properties, the one I mentioned, exist together. There are situations where if you try to have one property, the other may not exist. Okay, so I mean, does that answer your question?
Yeah, thank you.
Yeah, so yeah. And we give an example in our proof in a Coq formalization that all these four properties doesn't exist in one particular example.
Okay, thank you.
Yeah. You can look at that detail on the paper. It is also available on the paper.
So I thought the question was, how do you prioritize which one?
Oh, okay. Sorry. Okay, I did not understand. I'm sorry. So prioritize. We ensure the individual rational property is the must property. Okay, and in stock market, the second most important property is the fair, and then it is uniform for the call auction session, and within the uniform you should maximize the trade. Okay, so that is how the priority is. So we give an algorithm which produces a uniform matching, which is also individual rational, which is also fair. You don't have to compromise on the size when you want to produce a fair matching. We have a proof that there always exists a fair matching of maximum size. And then
Oh, looks like there is a connection problem. Suneel, do you hear me? Oh, I'm so sorry. Maybe it was my connection.
I can hear you.
Okay, thank you. So we still have 2 more minutes. So is there any? So you use Coq to formalize your right?
Yeah.
But is there any aspect of Coq that makes your proof easy or hard?
There was one issue we faced in the proving that the existence of fair matching without compromise on size. Our difficulty was there was no projection functions available, so we needed to write a lot of projection functions because bit may have other informations, and a lot of inductive arguments works only on the projection. Okay, so that was a little small challenge we had. And we have not used any axiom for our entire formalization. So that is something,
Okay.
and it was only, yeah.
Thank you.
Yeah, okay.
All right. Another question?
Yes, actually, I have a question.
Okay.
Right. So you mentioned a lot of properties and some algorithms. Can you find these in an economics textbook, and along with the proofs and definitions, everything?
Yeah. All the four properties are. It is a very. It's available on the literature of double-sided auction. They are very popularly known and they are well studied. Some of them are well studied.
Right.
But
so,
for continuous market,
continuous
market, we don't have such theory. And the other issue is that this theory is not available for multiple quantity. Most of these properties are available for single unit. I mean, single quantity, sorry, not single quantity of request. Now we are generalizing it to the multiple quantity unit, because in the actual market, the algorithm uses the multiple quantity. Yeah.
Right. So a follow-up question might be, so basically you have to port these definitions and proofs into Coq, and maybe that's related to Yo-Yo's question, but I'm wondering whether you have to make some kind of adjustments to the textbook proofs to make them work in Coq.
Yeah. So that is true. Like for example, in the textbook proof of exist fair matching, it just simply says that take the like pick up any two arbitrary bit and see if the larger one is not available, then replace it with that. Whereas in the Coq proof, we need to give the proper inductive argument, but the proof available in the textbook is not inductive. That was one thing. I hope that, and similarly, other proof, a maximum matching algorithm is also not inductive in the literature we followed. So we gave a recursive algorithm and then we proved using that. So the proof is ours. So that is not available in the literature. All the proofs are ours. Yeah.
Right. Thank you.
Okay.
Okay. So let's thank the speaker again.